the green light. And the light bulbs that simulate the inrush, that replace the inrush, they didn't light up, so that's good. This here's an old TV repairman's trick to use light bulbs in place of a fuse. And right here is a blown inrush, and I've got those light bulbs attached to the board where this inrush used to sit. What happened was the MOSFET shorted out. Right here's there's 4 MOSFETs in that power supply, and 2 of them shorted out. I'll show you that in a little bit. Let me fire this thing up. Look right there, you'll see the LED come on. But what happens is, if we still had a problem in this power supply, this switch mode power supply unit, the light bulbs, for instance, if we had a short circuit or if it locked up, the light bulbs would turn on very bright, and they would dissipate that short circuit energy into the atmosphere as heat, and they would protect the new IGBTs that I put in there. Okay, so let me turn that on real quick. There. We got a green LED turned on right there. Let's see what our output voltage is. It's supposed to be 24 volts DC on the output. We got 24.86 volts DC right there. That's good. I could take those light bulbs out and put the new inrush in. So it's got 4 new IGBTs, and each IGBT is part number IXFH9N80 by IXYS, IXYS. And the inrush, here's the new inrush. And we were lucky enough to where we could see the part number on the old one. It's a PTC B755. That's the new inrush to replace that blown. Alright, I'll get those light bulbs removed, put the new inrush in, put all this back in its housing, and we'll fire it up again. I've got the inrush installed down here, and we're going to fire it up again, see if it works. Watch this green LED over here come on. Look at that. All right. Oh, we're good to go. Let's see what our voltage is on the output. Can y'all see that? 24, get on there, 24.85 volts DC. That's a good power supply. Let's put it in its housing. I'm going to turn off the line voltage. I've got 380 volts AC 3-phase coming in here. I'm going to turn that off. Disconnect it from the wall. Right. Okay. We gotta let these bus capacitors discharge. We had about 525 volts DC across these bus capacitors. We gotta let those discharge for a little bit before we start handling this thing. We don't want to get ourselves lit up today. I'd like to live to another day if we could. So we'll let that as discharge. Alright, it's been a little while. Let's turn those over. We'll measure what our voltage is across those bus capacitors. You want to be very careful with this high voltage. Here's one bus capacitor. Okay, we've got 5.4, 5.3, 5.2. It's discharging. It's not very much. And here's the next one. These are in series. We got 3.8 and dropping. Let's go across both of them. Total voltage is 6.4, 6.3. So it's going down. It's not 525 volts DC no more. Go bring the parts over here so we can start putting this back together. Be back in a little bit. What you want to be careful about is there's a couple of power diodes over here. You want to make sure that you insulate those from the housing. And here is another power MOSFET right here. You want to make sure that it's insulated also. Just set that back down in there. Go. Dump the screws out. These little clips hold those devices to the housing. Separate those guys over that way. Insulators in. Go on, get in there. There's that one. Here's the other one. Now we'll get the clips installed. Make sure we're insulated. You don't want the metal tab. That device touching the metal housing. The metal housing is frame grounded. If the metal tab is touching the housing, that'll create a short circuit. Now, these are kind of tricky to get installed. Sometimes I can and sometimes I can't, but I get one side started. Then I try to squeeze this other side down with this long needle nose pliers. Sometimes I can, sometimes I can't. left-handed and I'm using my right hand to get it going. There we go. There's that one installed. I'm going to do the same thing here. Get one side started. Hold it in there. Squeeze the other side in with these needle nose pliers. There we go. We got that one. There's those two installed. Now for this one. Make sure we got good insulation on the back side of that one. Okay, that's good. I'm going to slide this one down here. And its tab has a little rubber device right there. Come on, get in there. Let's get that one side started. And squeeze this side with the needle nose pliers. There we go. Alright, we got that going now. And this inductor goes right here. You get those turned around like that. And this holds the inductor in place. There's some, looks like rivets right here that the iron core sits inside of. Let's get this side going. This is a little bit tricky. You need like 3 hands to get this one in, but it'll go. There, okay. That one you can do by hand. There's not as much tension on that holder. Right. All we gotta do is put the cover on it. That's what these screws are for. Stick those back in the little parts bin right there. Let me show you the shorted devices. One other thing I do, you'll notice there's capacitors in here. I replace all of these capacitors right here in that switch mode power supply section. Here's the switch mode power supply right here. Let me get my close-up glasses on and I'll tell you the port number. It's UC3526 ADW. That's it right there. But I replace these capacitors, whether they're good or bad. If I've got a blown up switch mode power supply, it's going to get new capacitors. The only ones I didn't change were these big bus capacitors right here. I'll get you close to this so you can see what's going on. I'm going to check them with my meter. These are the 4 power devices that I removed from that Siemens SITOP power supply. They're N-channel enhancement mode power MOSFETs. These two in the middle are shorted. And let's check those first. I'll show you. Put your red lead on the gate, black lead on the drain, and there we got 0.000. That's shorted right there. Let's put our red lead on the source. The drain to source is shorted. Shorted through and through. Let's move that one out of the way. Now this one right here is shorted also. Red lead on the gate, black lead on the drain, 0.001. Let's put the red lead on the source, 0.000. That's shorted all the way through. We'll move that one out of the way. Now here's something that you all can do to check a good one. We're going to turn this MOSFET on. Let's put our black lead on the drain and our red lead on the source. We get a diode drop of 0.405 volts. Diode drop. Now let's put a red lead on the gate, leaving the black lead on the drain. Now move the red lead over to the source. We've turned it on. It's a diode drop of 0.002. Now to turn it off, leave the red lead on the source and move the black lead to the gate. Now move the black lead back to the drain. And there we're turned off again. 0.406. Isn't that amazing? That's a good one. Let's move that out of the way. And we'll check this last one in the same manner. Put your black lead on the drain and red lead on the source. We're turned off. 0.411 volt diode drop. Now move the red lead to the gate, leaving the black lead on the drain. Move the red lead back to the source. Look at that, we're turned on. 0.002. Now to turn it off, leave the red lead on the source and move the black lead to the gate. And move the black lead back to the drain. We're turned off again. 0.411. Isn't that amazing? So we have 2 good and 2 shorted. Alright folks, thank you very much for watching, and we'll see you next time.